So Anthropic previewed Claude Mythos this week. Codename only, no weights, no API. It's rumored to be about 10 trillion parameters.
The federal government is now really working with Anthropic to see the extent to which this is dangerous. This does feel like it is different and people are paying more attention to it. But they've also been in the news because of supposed degradation in their existing models, namely Opus 4.6. One of her engineers reported that before, he was able to run 50 agents and they all produced excellent work. Now, this engineer says that every single one of these agents is a total idiot, end quote.
Llama's dead.
Llama's dead.
And the replacement, specifically, I think this is of note, is a closed source model that Meta is being weirdly candid about. Quote, Muse Spark doesn't mark a new state of the art, end quote.
They had this massive open source community project. Tons of people were using these Llama open source models back in 2023, 2024, and now they're kind of falling behind.
And welcome back to the Pre-Train Pod. I'm Pierce Freeman.
Hey guys, it's Rich. Pierce, how was your motorcycle class?
Oh my God, this is crazy.
I can't believe you're going to get a motorcycle.
To be clear, because
I can't believe you're getting a Ducati.
I'm not getting a Ducati. I'm getting a manual Vespa, but it is a manual because I really want one from like the 1970s.
And you're taking it on the highways.
19
Unbelievable.
I'm certified to go up to 120 miles an hour. The guy that was teaching this class said that his max speed that he ever got up to was 175 miles an hour on his Harley on a closed airport strip.
Oh, I was going to say.
Yeah.
That sounds super illegal.
Sounds super illegal. And this guy's like a CHP authorized guy. And then he clarified. He was like, yeah, I've gotten up to 175 on the Harley on a closed course.
What is that? 300 kilometers an hour? That's insane, dude.
Yeah. Totally.
It's like a third of like
you do an European conversion. Jesus Christ.
Hey, dude.
You're as American as I am. Shut up.
I do not.
I do not. I do not. These imperial. What is food? All right, Richard. I think we have a good show today. We're going to be talking about Claude Mythos, which is the latest model from Anthropic, beating all the benchmarks. Some Claude model degradation that has the internet all up in arms. Muse Spark. Gemma 4, and then maybe some fun at the end of the hour.
Okay, let's have some fun, dude. Let's
have
do
some
it.
fun. All right. We have to start with Mythos because I think this is the most interesting model card Anthropic has put out since the original Opus. And I want to talk through what they're actually doing before we see whether or not any of it holds up. So Anthropic previewed Claude Mythos this week. Codename only, no weights, no API. This is like a closed release that they've just done for a select group of partners. It's rumored to be about 10 trillion parameters, although like every closed model these days, no one really knows. And anyone that tells you that they know is actually lying. It's the first real size bump to the Claude line since Opus last year. Headline benchmarks 100% on SciBench, which means SciBench is now saturated and we probably need a new one. And 97.6 on USAMO, which as far as I'm concerned is basically saturated too, right?
Yeah.
Also threw out that in their actual model card, they indicated that they don't see that there's any sort of like evaluation time hijacking, which we'll talk about with some of the other models later. But I think the real story, Richard, the reason why Powell and Besant were sitting down with the big bank CEOs this week, according to CNBC, is the Cypher capability section of their model report. Anthropic is claiming Mythos found thousands of 0 days across major operating systems in every major browser. Many discovered and exploited, quote, entirely autonomously, end quote, which includes a 27-year-old remote crash in OpenBSD and a 16-year-old FFmpeg bug.
Okay, so OpenBSD. So one of the big operating systems back in the day was this thing called BSD, right? And this was a closed source Linux version operating system, I believe created at Berkeley. And OpenBSD has been this open source project that is basically an open source version of BSD that's been around since like the 90s. So the fact that they're saying that they found a 27-year-old remote crash bug in OpenBSD means that they basically found a bug that's been in this open source operating system basically since its inception. And no one has caught it in the last 27 years.
Yeah, that's exactly right.
Which is insane. So that's a big deal. Like whenever you find a bug in an operating system, that's kind of as deep as it gets, right? If you can hijack the operating system, you've kind of won as a hacker, right?
Yeah, fully, because there's nowhere else to go from there. If you control the operating system, you can literally do whatever you want within the contents of the operating system.
Exactly. And similarly, FFmpeg is this like audio conversion tool, I believe, right?
It's all media.
But it's all like media conversion. Yeah. So again, whenever you find a bug in these like low level tools, it's really dangerous because you can hijack many parts of the computer, right? So here they found a 16-year-old bug in this very widely available and commonly used tool called FFmpeg. It means that there was this bug that was out there lurking, and it's only now, many years, decades later, that we finally found it with tools like Mythos.
Totally.
Yeah.
And now it is possible that this is an already discovered exploit that just hasn't been published yet. Like conceivably, because these black hat hacking groups, which are kind of like the bad guys of the hacking community, will create these exploits that they'll then keep safe in some vault and then reveal to clients that pay them. So like,
So these are the bad guys.
These are the bad guys. Yeah. So usually in like the cybersecurity community, the white hats are the good guys and the black hats are like the bad guys.
But the black hats in this case, they're not necessarily the hackers here, right? Like they won't hack your system. They'll just sell you these bugs that they found.
Exactly. So it's like the NSO group that I think is like these ex-Mossad guys in Israel. They're pretty well known as being like one of the core like pay-to-play hacker groups. So if you're trying to spy on someone, then you can pay $2 million for some 0 days.
Okay.
And as software has gotten more secure, the price of 0 days has been increasing dramatically because there are fewer 0 days for these groups to find, but they still kind of like maintain this cache of exploits. I think to people who ask, what the heck is OpenBSD? Why is this important? I use Mac. I use Windows. I think the history of OpenBSD is pretty interesting here because it was one of these Unix projects when it first came out. And a lot of the source code that they put into OpenBSD has been utilized for other things.
Yeah, isn't Mac a derivative of OpenBSD?
Mac is a derivative of Unix, not OpenBSD directly.
It doesn't branch from OpenBSD?
Not directly, but because it has the same underlying layer, you can end up using a lot of the code from OpenBSD in something like Mac OS X. Yeah. So specifically, the firewall code on Mac OS X, even today, is based on OpenBSD's PF firewall code. Android's Bionic C standard library is based on OpenBSD code, and LLVM uses OpenBSD's regex or regular expression library for its parsing. So it's like these things aren't directly using OpenBSD, but they're sharing a lot of code with it, which conceivably means that if you find a remote crash in a certain component of OpenBSD whose code is utilized in a lot of other places, you have also found exploits for those operating systems too.
It's kind of like, how car manufacturers, like there'll be a car group like the Volkswagen group that will create, obviously like they own Volkswagen, but they also own Lamborghini and all these other brands. And so there'll be parts in the Lamborghini that are actually shared with a Volkswagen, right? Or like a Golf. So this kind of seems like it's one of these things where even though maybe here it's only the Volkswagen Golfs that were affected, because they share some parts with a Lamborghini, the Lamborghini could also be affected in this analogy of, there's a bug in the software, like the parts used for these cars.
Yeah, 100%. I'm thinking of literally based on our F1 conversation before when Red Bull decided to go with Honda.
Yeah,
engines.
They buy the engines.
Yeah, exactly. It's like you're just kind of creating the wrapper. So that's actually what a lot of software ends up being. It's like, why reinvent the wheel when some other talented engineer has done it before? That's a whole idea of open source.
Right.
FFmpeg also open sourced. And you kind of hope that with these open source solutions, because there's so many eyes on it and so many dependent projects that are also dependent on those things, people have done the sanity check to really try to find these vulnerabilities within the core source code that everything uses. That's largely been an assumption of open source that like, oh, it's more secure than closed source things because you just don't know. There's like no auditability for closed source. Clearly, there's still bugs in open source software.
Yep. Yeah.
One other fun fact here, on Firefox 147 alone, VentureBeat reports that Mythos wrote 181 working exploits versus only 2 that Opus 4.6 found. And according to NBC, this is the first time in nearly 70 years that a frontier lab has publicly withheld a model over safety concerns. The last time, if you remember, was
GPT-2.
GPT-2, which by modern standards seems like the dumbest model possible. Like your phone has more compute ability to run a language model than GPT-2. So I feel like that raises the question of, are we just going to look back at this moment in 2 or 3 years from now and say, this was totally overblown. This model actually wasn't that powerful. Yes, they found these vulnerabilities. But on another hand, there are maybe some of these other models that were able to find these vulnerabilities too, at least when pointed in the right direction. So like, where do you paint this delta of like existing capabilities that we have in Sonnet, Opus, or GPT-5.4 and this new Mythos release?
I think it's pretty telling that before they released this white paper, the Anthropic leadership team actually met with Jerome Powell, the Fed chairman, Scott Bessent, and some of the other big bank CEOs. I think the only one who wasn't able to attend was Jamie Dimon.
Mm.
Is that his name?
Yeah, the JP Morgan.
JP Morgan guy, right? Yeah. So basically everyone else, all these other
prolific on Twitter too.
Exactly. Everyone else attended. So it does feel to me that there is something here, right? That these powerful folks in the United States,
they're worried about it.
They are worried about it. And, these bank CEOs who have actual money on the line here think that this is important enough to actually meet with Anthropic's team and to discuss what the dangers and implications of Mythos could be. And we should also say that it's unclear when they're going to release this, right? So in some sense, we'll find out whether this was all, smoke and mirrors in a couple of months from now, if companies like Google and Apple don't find any other big bugs in their code base.
Because Anthropic has said basically, we're going to let a preview group of people bug test their own software, like big software companies, big banks, etc. And once they've done that for some period of time as part of this like Project Glasswig initiative, then they'll release it to the public.
Yeah, that's the idea. So I think it's like 7 or 8 companies that are, like premium partners or something like that with Anthropic. So as I said, Google, JP Morgan, Apple, all these big companies. And it's unclear how long they have to use this tool before it's released into the public, but they're kind of doing the job for us, right? They're the ones, these companies are going to stress test whether this is actually something that we should be worried about, or if this is just another GPT-2 thing where it feels like it's important, but then in reality, when put under scrutiny, it's actually not as dangerous as we think it is. But what is interesting to me is that the federal government is now really working with Anthropic to see the extent to which this is dangerous, right? I don't think that was really the case with GPT-2. This does feel like it is different and people are paying more attention to it. And I'm curious to see what happens.
I mean, I've talked to a couple of my friends that work at Anthropic, and they've had access to this model for a couple months now as it's gone through various series of checkpointing. And they say that this is the real deal.
Yeah, that's what I've heard too. Yeah,
I don't think that they have much incentive to lie about this model being their daily driver, aside from maybe their stock options. But even that aside, they say this is a big daddy model. Its capabilities are like really outstanding. And when they've been using it in their work as like a preview capacity, they have been shocked by the code that's written and the things that it's found in their own code base. So at least the internal testers, I think, are pretty impressed by these capabilities in a way that's not just PR mumbo jumbo. And I think to be able to see that, you can really read the system card where it's easy enough to bullshit your way through a press release or a blog post when you're talking about some of these model capabilities. But this thing's like 150 pages. I mean, it's a really lengthy, like detailed breakdown that includes almost all of the metrics and ablation studies that you would want to see from a model. The only thing that we don't have access to, like you and me, is the model itself.
Yeah.
So we can't ask questions, but aside from that, all of the behavior that we would probably want to do testing on, they've already done, and these are the release. And I've heard nothing to contradict that testimony from any researcher, both at Anthropic, but also researchers at Google and Apple that have access to these models.
I think what people were so impressed by with this model is that it is so diligent in trying to find these exploits, and it won't just give up initially. So there's this one exploit that they detail in their model card where the model, if you look at its thinking tokens, knew that there was some exploit here, but there was some limitation to it being able to actually exploit it. Like there was some networking issue that it couldn't overcome. And so it actually went and like rewrote part of the networking stack in order to be able to take advantage of this exploit that it knew existed. And that's crazy to me, right?
Yeah.
Because that requires a level of sophistication that is at the level of like Mossad or the CIA, right? Where you're rewriting the super low level code in the networking stack that for most programmers is just way like above their wheelhouse. So I think with Claude Mythos, the thing that feels like a 0 to 1 moment is its ability to not only search effectively, search over the space of possible exploits, but once it finds something that seems a little suspicious, its ability to really just keep hammering at that problem, create new code, create new software packages so that it can actually exploit that, right? Because you should say there's a difference between knowing that there's some vulnerability and actually being able to exploit that. There's sort of this tension between the two, where it's much easier to find something that seems suspicious, but then actually being able to attack that effectively, that's in some sense the harder part. It has a dog in it, It really wants to get at this exploit and find these solutions to how to, take advantage of these vulnerabilities in our existing systems.
I wrote this blog post a while ago about the tenacity of modern language models, which I actually think is holding up pretty well, not to toot my own horn. But it was basically this argument that in each successive generation that we've had, these models are getting better at taking a problem scope that you've given it initially and exploring it from every possible angle past the fatigue point that any human would otherwise probably give up. And I think that is showing to actually be scaling with the scaling laws as well, where these models are both getting smarter, but they're also just getting more targeted and they're willing to explore every surface area that's possible for this problem. And I think it turns out for most problems, if you give it enough time, tokens, and surface area, there is something to be done. There's is a solution to be found. You've just got to try different things and collect data as you're doing them.
I think sneaky, the secret sauce of these models is their ability to compress their existing context window into a smaller set of tokens so that they can keep reasoning past their initial limitations of their context window size, right? So these models are usually trained with like a 1 million token context window. But the way that they overcome that, and you might have seen this in Claude Code, is occasionally it'll compress the existing conversation history into a tiny version, to a summary effectively of what's been going on so far. And these models like Claude Opus 4.6, and now I imagine Claude Mythos even more so, are really good at compressing the existing history. And it gives you the sense that these models can just keep reasoning over the same tokens almost to infinity, right? Because it just keeps summarizing. It keeps generating more tokens, summarizing, more tokens, summarizing.
More tokens,
summarizing. And so Mythos, I imagine, has this ability that Opus already has tenfold.
Taken to the extreme.
To the extreme.
Totally. I mean, I feel like one thing that is weird here that is different from regular software engineering is there's not a whole lot of available source code for vulnerabilities. You kind of know what I mean?
Like data sets of bugs?
Yeah, exactly. You can really see, even if you just see LLMs as pattern matching machines of taking some existing corpora and applying it to new novel situations, which is why it's really good for software engineering and not yet that good for AI research. Security, there's actually not that much in the public domain that shows these vulnerabilities.
I can't believe the CIA doesn't open source their data sets.
It's just fuck wild.
Come on, man.
Come on. Put it in the comments.
That's right,
please. Dude. White hats do this. So we were talking earlier about this whole black hat, white hat divide. The white hats are these good guys that go out and have fun trying to find these exploits, but have some responsible disclosure policies that they tend to operate by, where they let the companies know if they found any vulnerabilities. And often after some certain time window, will publish those vulnerabilities as a way of putting pressure on those companies to fix the vulnerabilities in the first place. So there are data sets online. There are GitHub repos that are dedicated to this. But if you stack the quantity of repos that focus on security to the quantity of repos that do literally everything else, like full stack app building, I mean, it's de minimis in comparison. And there's definitely something to the whole reinforcement learning process in these simulated environments that they're intentionally trading Claude on for it to be able to do this, given the fact that the data set just isn't really there in the first place.
Yeah, it feels like Alpha Zero, right? Where the model's almost self-training on its own data in some sense. It will be really, really cool at some point once they open source more of the actual underlying technologies that they use to figure out how the hell are they doing this.
100%. The one last question that I have here, Rich, is specifically in regards to this searching out of exploits, where there was this company or group called Isle. Do you hear about this?
Yeah, I saw this. I actually hadn't heard of them before. It's just a company, right?
Yeah, I guess. It's like a research lab. So basically, these guys took some random open source and then cloud hosted versions from the previous generations and attacked these same code bases in FreeBSD and FFmpeg. And they found that these open source models were able to find these exploits too, to which their takeaway was, Mythos isn't that impressive. There's nothing to see here, folks. Old models could do this too. But the nuance between those discrepancies is that Mythos was just given the code base, and here these open source models were directed at a specific part of the code base in order to exploit. So it's basically the equivalent of saying you have a whole farm and there's gold buried somewhere within it. Mythos, go find the gold, right? It's traversing the whole farm. The other one, you're saying, hey, I think in that corner,
right, totally,
maybe there's some gold.
It's so dumb.
You want to go find it, right?
Yeah, I mean,
totally. But I think the thing that I don't know, Rich, is it in fact them just giving Mythos the entire FreeBSD source code and saying, go find bugs? Or is it them trying to refactor the code into individual functions, pass those into Mythos, and then have it do that same approach? Kind of like, again, you're segmenting out your whole farm into a grid and then having separate Mythos instances trying to dig in each spot. In which case, then, ostensibly, the open source models could probably do that same thing. I guess then it's just a question of the recall of the bugs that they've found and whether or not there are any hallucinations. Like, is this a question of Mythos being more precise with being able to find these bugs? Or is it actually that there's net more recall associated with these bugs that these other models couldn't find?
I think the question here basically boils down to what was the prompt given to Mythos? And we don't know that. But from reading the Red Team preview that they came out with, so Red Team is this group at Anthropic that basically deals with trying to see what are the limitations and what are the extents to which you can exploit these models. My understanding of it is that the prompt was really open-ended. If I'm reading this right, they basically just pointed at OpenBSD and said, just find something. And again, like the nuance here isn't that Mythos was able to find a vulnerability when directed to look for one. It's that it found something in a massive search space, right? It was just told, do something with this code base. And it was able to find this really super niche vulnerability. I mean, that is the 0 to 1 sort of step that we've taken from Opus 4.6. And I think that is corroborated when you look at these actual benchmarks, where I'm looking at it right here, and we can show this in the show notes. Opus 4.6 doesn't basically find a single successful exploit in this Firefox JS shell exploitation attack. Mythos preview finds like 80%, It's like a 0 to 1 moment. So I tend to think that this is the real deal and that they were able to actually successfully train a model that has this emergent capability of finding these really tricky bugs with basically no prompting, but time will tell. And time will tell because Apple, Google, JP Morgan, AMD, they're all using this preview version, and we'll find out hopefully soon enough if they were able to successfully find and patch any of their bugs.
There are a lot of smart eyes on this.
Yeah, I just hope that they're honest, because obviously if Google finds some massive vulnerability in their code base, they're not going to be incentivized to say, oopsies, we had this massive vulnerability thanks to Mythos, right? They're probably going to have try to sweep it under the rug a little bit.
Well, maybe they'll just ask Gemini Pro 3.1 to find the same bug.
Oh, that's right.
Then they'll release that.
They'll release that
Some
instead.
big claim.
Yeah, exactly. Yeah.
We'll see.
Speaking about Claude Mythos. I mean, obviously, Claude has been in the news this week for this amazing model Mythos. But they've also somewhat ironically been in the news because of supposed degradation in their existing models, namely Opus 4.6. And here's a number I can't stop thinking about from this week. In one report filed as a GitHub issue by an AMD director of AI, Stella Lorenzo, it's reported that the thinking depth of Claude Code has actually reduced substantially since the original release of the model, and has actually reduced by roughly 9 times the amount after the March rollout. So that means that prior to March, in February, the model was doing 9 times as much thinking as the model was doing in March and April. So people are really confused what gives. So as said, Stella Lorenzo, who runs this AI group at AMD, published this issue on the Claude Code GitHub page and basically said that Claude Code, as of April 3rd, had become completely unusable for any complex engineering tasks, end quote. And unlike most of the complaints, she brought basically these massive sets of receipts. So she took a bunch of the sessions of AMD engineers, I think roughly 7,000 sessions, 250,000 tool calls, this massive log, and was able to show that on this GitHub issue to actually prove that, Claude Code had provably gotten worse in the last couple of months.
It's pretty damning.
It is very damning. Yeah. The other thing she points out is that the reads per edit, so I guess that's how many times the agent looks at a file before rewriting it, has dropped from 6.6 to 2 after this March thinking redaction rollout that she pointed out in her report. And blind edits tripled from 6% to 33%, right? So something is going on here.
Mm-hmm.
To summarize her complaints, there's one quote from this issue that she wrote where she writes that one of her engineers reported that before he was able to run 50 agents and they all produced excellent work. Now, this engineer says that every single one of these agents is a total idiot, end quote. So, Piers, what gives? Do you think that they're being fair here in their analysis? What would be the what's the Anthropic side to all of this? Have they responded?
Yeah, so Boris has closed out this ticket, so they don't think it's an issue.
So Boris
Specifically,
is the
is the
lead
lead
maintainer.
engineer. Yeah,
Yeah.
exactly. Like team lead inventor of Claude Code.
Yeah.
And the claim from him is that the change that she was citing as something that adjusted this redaction of these reasoning tokens is UI level only and doesn't actually touch the reasoning logic that they're doing in the back end. So like the tokens that the model is seeing should be the same as they were before this release. And they're doing the same amount of thinking behind the scenes. So you'd expect the results to be the same.
So Boris is like, you're tripping. Like what you're seeing here is basically just what you see on the screen, but behind the scenes.
That's exactly right.
It's doing
We're
the same
doing
amount
the
of
same
thinking.
thing. Like we've checked, the models are doing the same thing. And I'm willing to take that at face value. I think that's probably true. This independent group token cost point out that the thinking depth, which they track, started dropping in late February before the March rollout of this feature, which happens to line up with Opus 4.6's adaptive thinking that launched with the default set to medium instead of high. So you used to be able to choose the knob of your model by default. And so you had some shortcuts to do this in Claude Code. Like if you said ultra think, it would automatically turn on high thinking. And usually, especially with engineering, like coding tasks, the more thinking tokens you spend thinking about the problem, the better code that you end up getting at the end of the day. So it's no surprise that if in fact you have erroneously configured your Claude Code client to have medium to low thinking, you're probably going to get worse code as the output to this, which is mostly what these AMD engineers have been noticing. I don't know if that's a coincidence or if that's a misconfiguration of some of these people's harnesses. You don't really know. I think usually you try not to push that configuration onto users that maybe don't know the intricacies of thinking tokens. Like you want the defaults to be as reasonable and in my mind as maximal as possible to give people the best experience. Because the only con with reasoning tokens is you just have to think longer.
Yeah.
And I guess it like wastes your quota, but you usually do get a better result. So if I were Anthropic, I would be looking at this adaptive reasoning to see, is that messing things up downstream? Should we actually increase the amount of default to a higher amount of tokens? I think the thing here that no one really has been able to corroborate or explain is why the amount of thinking tokens varies so heavily by time of day. So in this report, they specifically said that 5 p.m. PST is the worst hour. Like the models think the least at 5 p.m. PST.
Because they're getting sleepy.
End of a long workday Pacific.
Yeah.
You know what I mean?
Totally
San
makes
Francisco,
sense. These things are becoming human.
You've still got like 4 more hours in the 996 grind, but you're
Right.
feeling the slog. You need to take a
Right.
Red Bull. And 7 p.m. is the second worst hour. And like pretty dramatic fluctuations, like hundreds of thinking tokens.
Post-dinner
different between these
drowsiness,
hours.
of course.
Yeah, bingo.
Yeah.
You know the vibe. And late night, 10 p.m. to 1 a.m., it shows recovery
Wow.
and increases back to like 800. So it kind of drops to like 300 characters and then gets up to 800 to 1,000 again. So I don't really know why this is. Anthropic has always said that there's not really any load balancing that they do across times of day that would change these behaviors. I don't know if that really is proven out by some of this data. It seems like there are some choices that are being made maybe behind the scenes to say, well, it's the same model, but maybe we're just going to instruct the thinking tokens to be a little bit more reduced if we have high load so we don't saturate our GPUs. Like what's going on?
I mean, look, man, the reality is that right now, Claude is not making money off of these $200 a month Max subscriptions. There's this report that I was reading that suggests that it actually costs between $1,000 to $5,000 in actual compute to power the usage of these Claude Max subscribers.
That's crazy. There's no way that's true.
To me, what that means is that Claude, maybe already, but in the near future, will have to start curtailing people's availability of these models. And will try to incentivize, in some sense, users to not use these models to the full extent that they're currently doing, right? And you already see this with them blocking third-party APIs like ClaudeBot from being able to take advantage of the built-in $200 a month Max subscription tokens, right, that come with the subscription. So something I think is going behind the scenes from the business side of Anthropic, where they realize that this thing isn't making them money. They have to figure out some way to actually make a profit off of these subscriptions.
Do you think it would be crazy, this idea that in some future state, people actually spread out their geographies in order to best get the tokens? Like I'm thinking this hustle culture vibe of going to Bali to get away from it all and to do remote work maybe will become advantageous in a world in which there is consistent compute capacity. And depending on your time zone, they're going to nerf the models more because there are more people using these. So you want to get off cycle of whatever the main metro hubs are.
Interesting.
You know, it's like people in Europe are going to use these, people in New York, people in California, Hawaii, Bali.
So should we just
Who
move
are
to
in those
Bali?
time zones?
That's right.
That's what I'm thinking.
Genius.
Little
dude.
remote studio.
I love it.
We'll see. All right, Richard, I want to talk a little bit about your favorite AI lab,
Oh yeah.
MSL.
Oh,
Meta
is it my favorite?
Superintelligence. I don't think so. They're pursuing super intelligence, Richard. I think this latest release is a little bit less than super intelligence. Maybe we can just call it rudimentary intelligence. It's the first model out of the Alexander Wang era, shipped April 8th, called Muse Spark. And this is a full closed source pivot away from the Llama lineage. So it's a completely different model, new architecture, whatever. Llama's dead.
Llama's dead.
Long live Spark, I guess, or long live Muse. It's got a whole
Good
different
name though. I do like the name.
You do.
Muse is, I think, pretty good.
So the base model is Muse, and then Spark is just the flavoring.
I suppose.
You know?
Yeah.
It's like vanilla with like chocolate chips.
Yeah.
Chocolate chips is the Spark. So, like I was saying, it is a whole different architecture. And the replacement, specifically, I think this is of note, is a closed source model that Meta is being weirdly candid about. Their own blog post literally says, quote, Muse Spark doesn't mark a new state of the art, end quote. So the numbers are basically competitive with the last generation of architectures, like Sonnet 4.6 and the old version of Gemini. They're not pushing the needle here with basically anything. They just got this model out.
And I don't think they're really even comparing with Opus 4.6. Their real point of reference was their old version of Llamas. Llama 4 is what they're benchmarking against.
That's right.
And they're saying, guys, great news. We're as good as the old model. We're just more efficient.
I'm as good as your old boyfriend.
I just don't know if anyone really buys that marketing,
So, well, I think their headline claim is that they matched Llama 4 Maverick's performance, which was the bigger Llama 4, at an order of magnitude less compute. So they basically figured out how to get the same level of intelligence just with like a really pared down model, which is maybe useful for edge compute if they let us distribute this on the edge ourselves.
Right.
But the fact that it's closed source means what? It's like cheaper for them to host?
I suppose.
Cool. You want to go through the technical details of how they were able to squeeze more performance out of this like smaller truncated model?
There's really just one trick that really stood out to me,
Yeah.
which is this RL compression technique that they're doing. So here's basically the idea. When they're doing reinforcement learning, they're building into the reinforcement learning objective function this propensity of the model to want to use less thinking tokens. Like it's built into the actual reward that they're passing into the model. And so what happens emergently is that as the model is learning how to perform these tasks, it starts off by thinking about the task, but then it reaches a point where it realizes that it's being penalized for thinking too long. And then it naturally, as an emergent property of the model, begins to try to compress its thinking tokens to a smaller representation. But then, interestingly enough, it then keeps thinking more. So this is something we've never really seen before. So unlike most models, where in the reinforcement learning phase, you just let it think for a while and then it performs the task, this model has this emergent ability of sort of like thinking and then compressing its thought process and then thinking more and compressing its thought process. Sort of like this dynamic generation and compression process that is novel. And by doing so, they're able to effectively train this model with less compute, is the big headline, right? So they have this new RL tool, but the actual architecture of the model isn't new, right? It's just this train time sort of like testing harness that they've built out, which lets the model adapt its thinking and compress it. That's basically it. The other thing that stood out to me is that maybe as a result of this reinforcement learning process, maybe as a result of its training data, this model is weirdly good at refusing to generate bioweapons. That was the other sort of big takeaway.
That's good. I'd say that's good.
Kind of random because as you're reading this report, it's like, okay, it has this reinforcement learning thing, which is interesting.
Yeah,
and
yeah.
by the way, it also really
Bioweapons.
won't build a bioweapon for you.
Sick.
So those are the two big headlines. So
I'm
there's-
happy to know that when I'm chatting with my little Meta assistant, it's not going to accidentally build me.
I know. I hate when it just
that's
generates like an atomic bomb for me. And I'm like, dude, no, don't do
No,
that.
no, bad opus.
So there's this data set, which I hadn't heard about called BioTier Refuse. I haven't interacted with this data set before, but the idea is, I guess, to probe whether the models will accidentally generate a bioweapon And this model,
I think when prompted, like if you ask it even intentionally, like build me something bad,
course.
then it won't.
And it's good at refusing. It refuses to do so 98% of the time. So don't worry, guys. Only 2% of the time does it generate
That's such a good point.
A bioweapon.
This feels like a good thing to optimize recall over precision for, if you ask me.
Yeah, this seems like it's a hard one of these like marketing tricks where they're like, guys, it's 98% of the time
right.
It won't create this catastrophic thing.
Sick. I will say the caveat to that, as far as I was able to ascertain, is I saw that Apollo Research flagged that Spark has one of the highest rates of evaluation awareness of any model they've tested. So basically, this means that it identifies these safety evals as test contests and behaves more carefully because it knows that it's being evaluated. We've seen these with some other models. Like I think Sonnet showed some awareness, kind of self-awareness of itself, because these examples are in some training data, or the way that the questions are formulated just seem overly pedantic. So the model gets wise, you know?
Right.
And it's not sentient, but it's just like, you know, that's
kind of realizes
what it's
what's going
learned
on
within its training data, reinforcement learning. Yeah, exactly. So I feel like that 98% number also deserves an asterisk, because, you know, how much is this already aware that it's being evaluated against this bio threat data set? I think to really be able to ascertain this, you would probably have to give it over to a red team and have them evaluate it. And as far as I've seen, I did not see that on the model card.
Yeah. I think that's super fair. Yeah, I wonder if they will ever open source this, because in their initial blog post and then sort of the tweets that I've seen surrounding this, the sense is, hey guys, this will be open sourced very soon. Give us some time, but we want to kind of go back to what we used to be, which is this open source pioneer in the industry. And we're going to take up the mantle from Alibaba and Quen, which have now actually become more closed source than they used to be. So we'll have to see. Time will tell if this is actually true or not.
I'm really glad you mentioned the whole Quen of it all, because I think you're right. Meta might have a little bit of competition in that space, though, as far as open models go. So Google this past week shipped Gemma 4 under an Apache 2.0 license, so open source like the rest of them. I want to get to the punchline first. With Meta closing the Llama lineage the same week, Quen's tech lead and post-training lead are both finally walking, according to Substack. This was rumored for a while, but it appears to finally be transpiring. And Alibaba, as part of this Quen group, is now rebuilding it from scratch with ex-DeepMind folks. They brought in a DeepMind leader in the company, and they look to be getting a lot more closed source with their models and the Quen family that's together, which is a big loss, because I know Quen was your favorite model. I think it's become
massive,
the steward
dude.
of the open source community.
Everyone has loved these Chinese models in the open source community. Quen, Kimi, right? These have been like pillars that people have used to build their startups on. That's basically how people do like AI in Silicon Valley. Is like you take one of these existing open source models and then you just fine tune them on whatever data you have. So this is a massive loss if we see these Quen models becoming closed source.
Yeah, I mean, hell, if any company wants to spend $5-10 million to train a foundational model and then let us fine tune the weights, to me that's just net win.
That sounds great to me.
But it's no longer these Chinese labs. Google is now somehow quietly the open weights leader. So with this Gemma 4 release, they have 4 sizes from the E2B on device to the 31 billion dense instruct model. They all have 256,000 context window, 140 languages supported, and it's an extension of this Gemini 3 research. So they're basically taking the exact or a similar model architecture that they do in their closed source Gemini releases, and they're releasing it under the unintentionally or maybe intentionally close name of Gemma. So it's Gemini 3 has now led to Gemma 4.
Gemma 4, yeah.
The stats are pretty wild in comparison to Gemma 3. AME jumped from 20% to basically 90%. Live code bench from 30% to 80%. And it's a full open source model, at least in terms of like the open weights. We don't actually know the inner canoodling that they have with a training recipe or anything. But it's Apache 2.0, which is good. Richard, how do you square this release with Google as an open weights leader with literally everything we said about them for the last like 3 years running?
It's a great question, man. I think for the longest time, it felt like Google was out of the race to a certain extent. And now it feels like Google has done all this research in secret in their ivory tower over these last 3-4 years, and they're finally releasing it to the world. So I've been reading up a little bit about the architecture of Gemma 4. There's a couple of things that I find interesting here. The first one is that Google has really pioneered this approach of per layer embeddings. And we haven't talked about this before, but I think it's interesting to double click on. So these models all have this idea of per layer embeddings built in, which means that rather than just having one embedding layer, and again, an embedding layer is this thing that basically translates a token into an embedding, like a vector representation of that token. Usually you have one that you pass into the model when you first pass input. Here, what's happening is that as you pass an input into the model, at every single layer, it's getting re-embedded with a different embedding layer. And that seems to be the trick that Google uses to make these models a little bit more expressive without inducing too much of a compute cost. And I should say, I don't really understand how that can be because usually the embedding layers are really expensive to train. So having a per layer embedding layer feels very expensive to me. But Google has somehow cracked the code when it comes to doing this sort of approach.
Maybe there's some like randomized projection and they're doing like, a LoRa adapter or like bridging out these matrices. I don't know.
Yeah, I'm not entirely sure either. The other thing that they're doing here is they're basically building in a mixture of expert models into each of these models. So this shouldn't be surprising because for the last couple of years, all models have been these mixture of expert models. And so again, the idea is that you have, your model will have multiple different expert heads that can be activated at any point. The idea here is that it can dynamically route a query to one of these heads at inference time, which is kind of cool. So Google has that built in as well.
Which usually does not increase intelligence, but just makes the model faster.
It makes the model
decreases
faster.
The overall amount of active parameters that you have to do for each new token.
Yeah, the model can kind of think about how much compute should I actually be using for this given input. So it's like this dynamic computation. The model's aware of how much compute it should be using and who it should route it to get the answer to, right? And the other thing that stands out to me, Pierce, is that many of these other architectural features are actually not novel. Like they use rope embeddings, which we've known for a couple of years is pretty much the state of the art. They use a standard shared KV cache. Global attention is always in the last layer. So the things that they've decided to put into these open source models are not novel per se. It just seems that these models are pretty good, right? So I'm excited to start using these. The one downside I will say is that they only have 256,000 token context windows, which compared to Opus, which has 1 million context window, is a little small, right?
What was Quinn's?
I want to say it might have also been 256. I would have to look this up. But again, Quen is a slightly older model at this point. I would expect most models to have 1 million context window at this point.
Which, as you said before, is mostly a question of compute memory that you have access to and the training that was done on the model to calibrate it for longer sequences. There's not many documents themselves that have 1 million tokens. So it's one of these calibrations that you try to do to, you want to train in the right zone to maximize the compute that you have. But yeah, 256, I guess it's long enough for most of these use cases that people are using it for in the downstream domain. We'll see if this proves to be a good fine-tunable model because I've seen really solid base models in the past that have been released that blow every benchmark out of the water. But then when people actually, like you and me, start to fine-tune them for what we want to do, they're just not that steerable. They're very entrenched in their ways. They don't want to change. I think one of the things that people really liked about Quen was you could, in fact, fine-tune it for basically anything, and it responded to the fine-tuning as well as it would for the original training.
Yeah, there's this idea that you have a base model, but then typically the model that's actually released is the instruction-tuned model, which is a version of the base model that's been tuned specifically by these companies to follow instructions really well. And so even though the base model might be really good, depending on how much time and effort they put into the instruction tuning, the model will show either a propensity to be really good at following instructions and continuing to be fine-tuned, or it'll just kind of poop out, even though it has the capacity to be a really good model, right? So there's this nuanced distinction there. I'm excited to see what happens. If I'm reading this right, it already has 400 million cumulative downloads. Is that right?
Yeah.
That's crazy.
I mean, CI pipelines will do their thing, give it at least a couple thousand. But yeah, I mean, totally. There's 100,000 plus community variants according to Google, which is pretty crazy. There's an interesting thing here that you see some of the labs doing in the US now where they have some pretty powerful closed source model, like the GPT family.
Yeah.
And then eventually they'll feel some obligation to open source some varietal of these models. So these happen with like the GPT OSS, 120 billion parameter models that were basically a distilled version of the internal GPT architecture just for a smaller model and maybe removing some of the training data or synthetically generating it with the original GPT. So there's definitely like a weird, I don't know if this is internal politics or what, or they're trying to keep some name ID in the public domain, or they're trying to let researchers use some version of their models so they can take advancements from academia and then push them back in their closed source models. But whatever it is, you really have seen every company in the US, besides maybe Anthropic, releasing an open version of their model at some point.
But you know what's so weird to me is that Meta basically placed all of its chips into this basket, right?
Yeah,
They
from the
said,
get-go.
we're going to make Llama this open source community run project effectively. And that's probably going to be good for our PR. It's going to be good for, hiring folks. And I don't know if that's really panned out, like they had this massive open source community project. Tons of people were using these Llama open source models back in 2023, 2024. And now they're kind of falling behind. And I don't know if any of these bets have really panned out for them. So time will tell whether, Gemma 4 goes the same way as Llama 2 and Llama 3. But as a consumer of these open source models, I'm stoked, obviously.
Yeah. It's good for the goose, it's good for the gander.
That's
All right, Rich. I think that covers it for new model releases.
Exciting week,
this
man.
past
As
week.
always.
Yeah, seriously. It's I don't love spending a ton of time talking about the specifics of these architectures just because I feel like things change so frequently. There's going to be 20 new models by the time we record
You're
this
not
next week.
impressed.
Well, I think for these specific groups of models, to me, this tells us something a little bit more deep about the positioning of these companies and what they're prioritizing internally. Like Anthropic is really going after this maximal intelligence at all cost framework. We didn't throw it in the episode, but it cost them 20 grand in GPU raw costs in order to find some of these exploits of like OpenBSD and whatever. So
it's crazy.
They don't care. They don't care about the GPU costs. They're going for intelligence at all costs. Gemma 4, they're trying to give back to the community, be stewards, maybe reposition Google as a little bit more of an open, don't be evil company. Like, I think you can read in a surprising amount of company politics by looking at how they're positioning these models and what they're talking about. And I think that's interesting to talk about.
I think that's right. Yeah. So
well,
will tell, man.
Yeah, seriously. Until next week.
Until next week, boss.
Later.
Bye. You know what's insane too is that like certain tracks they'll just be too dangerous as the cars get better. Like this was the whole bit with the Nürburgring. So the Nürburgring used to be famously like one of like the top F1 race sites. So you can still race on the Nürburgring on like really fast cars.
Yeah.
But the new F1s are just so fast that there's certain parts where even with like a ton of downforce, cars would just like lift off. So this is famously Michael Schumacher.
Yeah.
Yeah. But he crashed here really famously because there's this one part where it's called Airport, where basically there's just like such a natural point where as the car like crests over this little hill, there's just so much like wind that picks up that if your car doesn't have a fuck ton of downforce and you're going 200 miles an hour, you will you'll fly. You literally launch for like 200 feet in the air. You should look up Nürburgring Airport. It's fucking wild.